Hey guys, welcome back to another video. And in this one, we're going to be talking about designing characters for survival games in Web3. Some of the thoughts that you should probably have, some of the learnings that I have come across from designing the Voxelverse. So, in survival games, your character is your identity. It's also the wallet, and it's the driver of the economy of the game. Okay, so it's also an economic agent. So we design characters that we hope are emotionally sticky, economically smart. So when we're talking about designing Web3 games specifically, we have our core game loop and then we have our core economic loop, and those two need to coincide in order to have a successful game. And this would be the same in Web 2. Like all Web 2 games and all games themselves have an economy. It's just how it's translated to the user, which may be different from platform to platform. So why is it central to have our character design intact when we are creating our Web3 games? Well, traditionally survival games are about scarcity, risk, and resilience, right? To change, adapt the gameplay behavior through obtaining different types of goals. Characters are the player's buffer between survival and death. Hunger, health, thirst, and mental state drive the gameplay loops. So if you notice, like in the Voxelverse, we have bars for, your happiness, the health of the character, different types of attributes. And this all changes, based on, life of the game, if you're eating, resting, tending to, specific activities inside the game world itself. So, what are some of the things that basically change when we are taking traditional Web 2 database driven games and moving a lot of database operations to the blockchain? Well, we have, a strict sense of ownership, designed through our NFTs, non-fungible tokens. On the Ethereum side, we stick with the ERC 721 specifically, or 1155s for things like, coins, or they could be just like ammo or seeds or things that you're going to have, one, but multiples of that one thing. The economics. So the characters earn, spend, and impact economies. Now, this is no different from a traditional Web 2 game. The economic layer, of course, is enhanced with a Web 3 enabled game. Permanence, progress, and mistakes are immutable. Okay, so as the player is doing these things, they're checking in, they're getting certain achievements. These are things that are written into the blockchain and they're immutable by that nature. In interoperability, characters live across games and seasons. Okay, so because we have this on-chain representation of the character, these characters and their attributes can also be moved into different games. As a smart contract engineer, you can access other smart contracts, read open data, and feed that into your games as well. So there's some core components that we need to go over. The ER721 token being uniquely around the character. So the specifics of an ER721, and all chains have a version of this, is that it's a one-to-one. So you mint one of these tokens, and that is unique. So the character, the token ID, the on-chain representation is unique to the wallet that minted that character. So there's some stats, and these are taken from the Voxelverse, where we have health, XP, hunger, thirst, and different attributes. The metadata, image, visual identity, and traits. Developers, this is very, very important. If you are designing games for characters, do not have the on-chain data on server somewhere. Do your best to write these things on chain. There's L2s that are very cheap. You can look at, chains like Beam. You can look at Scale. That very a lot of the L2s are cheap enough where you can write or sponsor specific transactions. Drip systems, daily rewards for engagement. This is talked about in previous lectures as well. Penalty systems. So, losing stats for maybe not checking in, or, the player, dips between a lower level of engagement, and then you start, knocking off at the character. Now, this is also an important thing as well, because you don't want players to be able to just earn rewards just simply for holding specific assets. You want players to be able to engage in the game and earn, and by them earning, they're actually giving back to the ecosystem, the game at large. Soulbound toggles, this is something that was designed in the Voxelverse main character smart contract, where for a certain amount of time, the character itself was soulbound, meaning that it was non-transferable. We do have a flag in there, and this will definitely be a vote from the community. Probably one of the first votes is to when the time unlock for characters to no longer be soulbound. So a reasoning for some of this is that early on in your game's transition from, alpha, beta to, a full release, is that you may want to have some of the core, beta testers from your community get in early, but you don't want this, premature trading of, maybe overpowered characters because they've been playing longer and been able to, grind before maybe others. So there's reasons for some of these, and we're all learning this as we kind of go along. Web3 game development is very, very new. So we'll find systems that, start working well or better. So very specific to the Voxelverse game, we did come up with, a drip economic system. So one of the main components that we were looking at in the design of this game is how can we have players who are engaging be funded for, playing the game and not have to, top up accounts or, things like that. A previous game that I worked on, a Web3 game, it had all the promise to being, the game of games. I personally believe, not just because I was working on it, but it had all the core components that a traditional game with an economic loop, and it was seamlessly tied in for the reasons why you needed the token in order to do X things, which was the first time I had actually really seen that done very well. But in the Voxelverse, we wanted to reward users for their engagement. So the things that they would need to do every day, if they were consistently playing, that drip would cover that cost. So this will reduce to, of course, like missed logins. You're going to get a lot of engagement from the fact that there's an incentive for these players to log in every day. And this is a traditional Web 2 game design methodology where you want to create specific habit loops to engage your community and players. Soulbound versus tradable. So we talked about this a bit earlier, where a soulbound token is non-transferable, and a tradable token would be, of course, transferable and trade it. You can put it up to trade and people can buy it. So soulbound, stronger identity, but limits the liquidity, right? So when you have tokens that you can trade and say that there's a economic outside kind of component where there's people who are grinding the game, building up these characters, overpowering them, and then selling them, and then rinse and repeating that, process. And that's very similar to what we see already in Web 2 games. And this is, something that is also transferable into Web 3. Tradable as liquidity, but it may reduce attachment. So you've built up this thing, you've gone through some battles, there's some, on-chain data representing some of the huge milestones that you've made. And now, if you're just building up these characters just to basically trade and flip, the game player itself may not have the direct link that was there previously. So the best option is toggable, soul binding, or unlock conditions based on, you've reached a certain level with this character. And once you've reached that level, then you can trade it. So say that there's like a max of a character. And if you've maxed out your character, then you can trade a maxed out character to someone else. So this is something that you really, as a game designer itself, are going to need to decipher, taking into account some of the economic incentives in Web3 and how that works, and the different player types or archetypes that we talked about in earlier lectures. And if you haven't seen those, I really recommend you to, go back and refresh yourself. So, as a case study, we'll talk about the VoxelVerse main contract. So, entities are mintable for free or for voxel tokens. So, to a certain level, you are able to mint this NFT for free, and then it goes on to the next stage where use the voxel token and to purchase the NFT. So characters themselves claim daily voxel rewards. So there's a certain amount of tokens that are in an issuance, and as the game, progresses, the issuance, basically goes down to there's no more left. So there's a stat decay after 3 days of inactivity. So if the character that you've minted, you're not logging in and checking in with the contract itself or logging into the game itself, then there are some penalties that are, taken on the character, and this is also, written on chain. Upgradable via gameplay or events. Okay, so since the Voxelverse smart contract itself is a the metadata is on chain, we can write that data on chain, right? So when you have metadata that is on a server, it's just a JSON blob, right? So the way that it's done in the Voxelverse smart contract is that the player's character's metadata is fully on chain. So the images for that are on IPFS, that's decentralized storage, and the metadata itself is on chain. So on chain metadata. So designing for player psychology. So this is going to be very specific to the game that you're designing, like bar none, right? So we're going to make the character story visible. And this is true with the on-chain metadata that we have in the Voxelverse, right? So if you think of like a traditional like Web 2 game, this is almost like a no-brainer, right? Like the character is starts at 100 health, and after a certain period, it's 80 health, and they log out of the game. When they come back in, they expect it to be at 80, right? Okay, and let's take that as a scenario. In a blockchain game, if we're building purely, decentralized game characters and game assets, then this needs to be written on chain. We can't transfer just an NFT and not have the data be on chain as well. Now, this does take into certain, aspects of things that you are doing. How much are you able to write this? Maybe you sync up on chain every, 10 minutes to cut down on the amount of costs. Or if you're on a system like, say Scale or another L2 that is very, very minimal in cost, like, Beam, and there's many others, then you can, gauge how much cost per stat update. And if you want to batch these things. So we create stakes, permadeath, exclusive traits for achieving specific things, rewarding commitment by staking, by having, say, like, a 1 month that you've done this every day, you get like a special badge that gives you like other types of perks, maybe voting rights, things like that. And punish apathy, right? So if they're just kind of, drifting around in the game, have them engage. Design the game to promote, incentivize, and to just make the experience, better when they are engaging. So the conclusion, fuse the identity, economy, and emotional depth with the actual character. This is traditional, classic game design. There's nothing different here. Okay. Risk is real, ownership is permanent, and progress is on chain. Please, game developers, if you are moving into the Web3 space, you need to make sure that this data is on chain. On chain metadata, look at the Voxelverse smart contract, get in contact with me. We can help you build out these systems. Build character players fear to lose and fight to evolve, right? So make this balance as the character grows and progresses in your game. And then you'll find that there will be just a direct engagement to the things you do. So that is the video. I hope you enjoyed this. You could take a lot of the traditional Web 2 character design and then mirror it with the beauty that we get from designing Web 3 games. And I'm going to see you guys in the next one. Thanks for stepping in. Drop a comment, smash the like button up, and Web3 gaming is inevitable.